the, the difference between electric propulsion of ships and electric propulsion of cars is that the highest torque requirement, the highest development of force for a ship occurs at top speed. And that means that you design, typically the motor will be designed for top speed operation of the ship. Automobile propulsion occurs across a very wide range of speeds. Now, typically the engine in a car has about a 10-to-1 speed range. An engine that idles at 600 RPM will redline at about 6,000 RPM. And in a car you need a gearbox in order to adapt the engine to the road. You can generate an electric motor that can propel an automobile without a gear shift. And the best motors for propelling cars are those that are adaptable to a very wide speed range. And I am of the opinion, I've studied propulsion of cars some, that the induction motor is the correct propulsion mechanism for automobiles. And the guys at Tesla Motors seem to agree with me on that, even though some other automobile manufacturers are still using permanent magnet motors for that application. Oddly enough, the electric propulsion destroyer that the U.S. Navy is using is also using an induction machine for propulsion, but there are other reasons for that. The distinction between induction machines and permanent magnet machines is, to my mind, that we'll step back one step. For any given electric motor, there is a trade-off between excitation, that is making the operating magnetic field in the machine, and reaction, that is providing current to push on that exciting field inside the machine. The exciting field in a permanent magnet machine is constant, cannot be adjusted. And so a permanent magnet machine that is turning very fast but making relatively little torque is dropping a lot of power in losses in the magnetic iron in the machine. There are losses in the magnetic iron. Whereas in an induction motor, you can back off on the excitation to provide torque at the energetically optimal fashion. And according to my studies, you can improve the drive efficiency of a car over a complete drive cycle by quite a lot, probably a factor of 2. I mean, it's not 2 in efficiency, it's a factor of 2 in losses, that is 1 minus efficiency. You really can do a lot better with an induction machine.